All right, this is a post video, so not a pre-video, of section 2.1. And there are a lot of these, the definition of a derivative, find it using the limit method, that take a long time to get through in class, so I've chosen to do a few of them in video format so that you can watch for more examples after we've done them in our class session. So the first one I'm going to work through is find the derivative of the following function using the limit definition that we're going over in Thursday's class today. And that is that the derivative of a function f, so at x, so this is f prime of x, that's the symbol for derivative, is the limit as delta x goes to 0, so the change in x is going to 0, of f of x plus delta x minus f of x all over delta x. So we've done this evaluation in class sessions, and we're going to now talk about how do we take this limit idea. So we're going to find the derivative of the first polynomial here, x squared minus 5x, and I'm going to write down my formula. So f prime of x equals the limit as delta x goes to 0. And then we're going to plug in, remember, those evaluations for that difference quotient. So f of x plus delta x, so I'm going to do this kind of over the side, is x plus delta x squared minus 5 times x plus delta x. You'll get used to this. We FOIL this out a lot. So this is x squared plus 2x delta x plus delta x squared, and then minus our 5x minus 5 delta x. So that's this evaluation of f of x plus delta x. So that's going to go on the top part of my fraction here. So x squared plus 2x times delta x plus delta x squared minus 5x minus 5 times delta x. And then remember, we still have another evaluation that we need to do, and I'll do this one in red. We have to do negative f of x on the top as well. So just remember, look up at your formula, f of x plus delta x minus f of x. Negative f of x just means change all the signs of the function. So we're going to put this at the end here. So minus x squared plus 5x. Okay? And then that is all over delta x. So here's how this limit process works. Right now, you cannot plug in 0 for all of your delta x's because we're trying to make delta x become or shrink down to 0, essentially. So if we plug in 0 right now, we would be dividing by 0. So we need to somehow simplify what's going on top and hope that we can cancel that delta x out before we can apply the idea of the limit. So if you notice, the x squared on top is canceled out with the minus x squared, and the negative 5x and the positive 5x cancel out. So this becomes 2x delta x plus delta x squared minus 5 times delta x. Everything on top has a delta x, so we can cancel all one delta x out of everything. So this would just be 2x plus a delta x minus 5, because this delta x canceled with one of each of those. And now we no longer have a delta x in our denominator, so we're allowed to evaluate this limit at delta x being 0. So this becomes 2x minus 5. So that is the derivative of x squared minus 5x. Okay, so I wanted to do just a couple more, and then I will move on to the pre-videos for next week. So this is going to be g prime of x equals the limit as delta x goes to 0. And this time on top, we would have, I'm going to do this one in blue this time. So this would be 5 times x plus delta x plus 2 times x plus delta x squared. And then we'll have minus 5x minus 2x squared. So notice this time I'm going to do my work in the limit, because after you get to a certain point, there's patterns to these, and you don't necessarily need to do all of that side work. If you do, and that's fine, but we're just evaluating these function evaluations. So this first part up top would be 5x plus 5 delta x plus 2, and then we have that trinomial, so that's x squared plus 2x delta x plus delta x squared. That is how this binomial right here always, when it's squared, will always FOIL out. And then we have our minus 5x minus 2x squared all over delta x. Now I still need to distribute the 2 on that top part right there. And notice I am not dropping my limit. It is coming down with me every time. You do not drop the limit off until you actually evaluate delta x for 0, which we cannot do right now because it's still dividing by 0. So this would be 5x plus 5 times delta x plus 2x squared plus 4x delta x plus 2 delta x squared, and then minus our 5x minus our 2x squared all over delta x. Okay, so on top, a 5x cancels with a negative 5x, and a 2x squared cancels with a negative 2x squared. So we're left with the limit as delta x approaches 0 of 5 delta x plus 4x delta x plus 2 delta x squared all over delta x. And I need to now cancel out my delta x's. Since everything on top has 1, we can cancel. And then this is now we can evaluate that at 0. So this would be 5 plus 4x plus 2 times 0. So just 5 plus 4x. All right, and then the last one on this video, because all the rest of these we're doing in class today, is 3x squared minus x. So we're doing f prime of x equals the limit as delta x approaches 0 of, let's do this in blue again, so this would be 3 times x plus delta x squared minus x plus delta x. Notice that binomial is going in for both x's, and then we change the signs for negative f of x. And then we want to work this out. So this time I'm even going to skip another step. I'm going to go ahead and distribute the 3 as I go. Just to show you how you could write this many different ways and still get correct answers. Because we already know that this FOILs out as an x squared, so that would make this then 3x squared. And then we would have a 2x delta x, so times 3 would be 6x delta x. And then delta x squared would times 3 would be 3 delta x squared. Then we have our minus x minus delta x minus 3x squared plus x. So I had to distribute that negative there all over delta x. So my limit as delta x approaches 0, 3x squareds are canceled out, positive x is canceled out. This is 6x delta x plus 3 delta x squared minus delta x all over delta x. Cancel out our delta x's. So that would be 6x plus 3 delta x minus 1, because this is delta x over delta x, which means it's a 1. Plug in 0 for the remaining delta x. And we get that this is just 6x minus 1. And part of today's lesson will be doing these limits, but we'll also teach you the shortcut method of how to take derivatives, but you are required to know both for the exam. Okay, so that are the extra ones that we're going to skip over, and hopefully that will give you enough to feel confident.